Hi friends, welcome back to Kasasvi. This is Vidya, and if you are new to this channel, please subscribe. And so many videos are there in a playlist regarding to this topic. And if you are already subscribed, please click the bell icon and never miss any updates from us. And comment, share, like. Now I want to share you about total disaster material, so please watch full video, don't skip, and please encourage me. If you are encourage me, then I will take to a step for more videos. Please subscribe, that is I want. Okay, now I want to start total distrust and material. Now let's get started. Data structure. Data structure is a collection of data elements organized in a specified manner, and accessing functions are defined to store and retrieve individual data elements. Data structure are sometimes called data types. Okay, data structure means a collection of data elements and organized in a specific manner and accessing functions. Specific manner లో organize చేసింటారు and accessing functions are defined to store or retrieve individual data elements. That is data structure. Okay, data structures are sometimes called data types. Okay, goals of a data structure to identify mathematical entities and operation. The class or of problems must be determined that can be solved by using these entities and operations. To identify mathematical entities and operations, the class of problems must be determined that can be solved by using these entities and operations. This is basically to understand how data structure can be viewed as a tool to solve the problems. Okay, data structure goals ఏంటి అంటే entities and operation. Class of problems must be determined that can be solved by these using entities, okay, and operations. To determine representation of these entities to implement the operation on these representation. Okay, next classification of data structure. Classification of data structure. A data type may be defined as a set, and element of the set are called values of the type. Okay, a data type may be defined as a set, and element of the set are called values of the types. There are four basics or atomic or primitive data type in C. Primitive data types ఉన్నాయి కదా Cలో int, float, char, double. Other data structure can build from one or more primitive data structures. Okay, primitive data structures. Simple data types built from following primitives: arrays, pointers, strings, records. With this we can build new types called structure or composite types. వీటినే structure or composite types అంటారు. Stacks, queues, trees. Okay, non-primitive this is. And linear data structure, these are stacks, queues and linked list. Okay, data types classifications, two types. One is linear data structure and another one is non-linear data structure. Okay, linear data structure is these are stacks, queues and linked list. Non-linear data structure, these are trees and graphs. Okay, next data storage. The possible ways in which the data items are logically related to define different data structures. Operations on data structure. creation of data structure, deletion of a data structure, insertion an element in a data structure, accessing structure in a data structure. Okay, stacks. It is an ordered list in which all insertions and deletions are made at one end. This end is called the top. If element or EDC be in order, then first element to be removed from the stack is A. Stack are also called LIFO. Okay, lost in first out list. Next, queues. It is an ordered list in which all insertion takes place at one end called rear and all deletions takes place the other end called front. Okay, insertion, deletion, A B C D A, stack, top, bottom, A is top, E is bottom, front, A B C D E. Okay, right. This is Q anamata. Okay, in this way రో లాగా ఉంటే అది స్టాక్ అవుతుంది, ఇలా కాలమ్స్ లాగా ఉంటే క్యూ అవుతుంది. ఓకే, క్యూ రిక్వైర్స్ దట్ ఫస్ట్ ఎలిమెంట్ టు బి రిమూవ్డ్ is the first one inserted, thus queue FIFO, first in first out. Okay, first in first out. Queue is first in first out. And next queue requires the first element to be removed in the first one inserted, thus queue are called FIFO list, first in first out. The simplest way to implement a stack to use a one-dimensional array of an element where stack is equals to array 1 comma n 1 dot n of items top. In this way we can write it. DQ. The term DQ means double-ended queue. It is a queue in which insertion and deletion is possible from both ends. DQ is an ordered set of items from which items may be deleted at either end and into which items be inserted at either end but not in the middle. Okay, operations. Remove left node from the queue. Remove right node from the queue. Insert left, insert a new node in the left side of queue. Insert right, insert a new node in the right side of queue. Okay, are you understand? Next, that is DQ. Next, linked list. Linked lists are special list of some data elements linked to one another. For implementing a list in a memory is to use a structure with self-referential structure. Linked lists are special list of some data elements linked to one another. For implementing a list in a memory is to use a structure which is self-referential structure. Struct node, int data, struct node link. Okay, linked list means this is the node. This node has two blocks, that is one data and other one is address. This address is referred to another data. In this way it passes the information data. Okay, A is goes to here. B, insertion. If you want to remove B, deletion B, that is move to this side. Okay, in this way. So the use of links require more storage but provide greater flexibility. There is no need to keep an explicit counter of the number of nodes in the list. Overflow is not a problem until the computer gets more exhausted. Queues can also be implemented as linked list shown in the figure below. This is the null. Okay, null. Two pointers, rear and front. Rear and front are used to point the queue. An empty queue is denoted by front equals to 0. Deletion are made at rear. The continuous storage is generally preferable when structures are individual, very small. Linked list provides superior when structures are large. Okay, next double linked list. Double linked list in which each node contains two links, one to next node to the list, one to the preceded node. Okay, one is next node, another one is, this is the double linked list, another one is shows next one, preceded one. It is not possible to move either directions through the list while keeping only one pointer with a doubly linked list. Traversal in either direction, insertion, deletion from arbitrary position in the list can be programmed without difficulty. The cost of double linked list is the extra space required in each node for a second link. Okay, next question, graph. Graph is a graph G consists of two sets V and E. V is a finite non-empty set of vertices. E is set of pair of vertices. These pairs are called edges. V of G represents set of vertices. E of G represents set of edges. G is equals to V, E is representation of the graph. The pair of vertices representing an edge is in order in an unidirected graph. Example, V1, V2 and V2, V1 represent the same edge. Okay, next. In a directed graph or diagraph, each edge is represented by a directed pair V1 and V2. V1 is a tail, V2 is a head of the edge. In the figure, G1 and G2 are unidirected while G3 is directed. Okay, this one is G1, this one is G2, this one is G3. G1 and G2 are unidirection, but G3 is directed, another one is, okay. V of G1, 1, 2, 3, 4. E of G1, 1, 2. Okay. 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. Okay. Next, V of G2, 1, 2, 3, 4, 5, 6, 7. E of G2, 1, 2, 1, 3. అంటే దేనికి కనెక్ట్ అయిందో చూపిస్తున్నారు. ఓకే, నెక్స్ట్ ద నంబర్ ఆఫ్ డిస్టింక్ట్ అండ్ ఆర్డర్ pairs VI VJ with VI is not equals to VJ in a graph of n vertices is n of n minus 1 by 2. This is for maximum number of edges in any n vertex under unordered graph. N vertex are unidirected graph with exactly n of n minus 1 by 2. Edges is a complete graph. G1 is a complete graph with n equal to 4. For a directed graph with n vertices, maximum number of edges is n of n minus 1. Okay guys, there are so many graphs is there. So you understood this all. If you like this video, please subscribe. Tree is also there. Tree is defined as a set of vertices such that there is a sequence of edges from any vertices to any other. Okay. There is sequence of edges from any vertex to any other. There are no circuits, that is no path starting from a vertex and returning to the same vertex. Okay, trees ki graphs ki different ఏమి అంటే this is the difference. There is a sequence of edges from any vertex to another. There are no circuits, there is no path starting from a vertex and returning to the same vertex. A tree is defined as finite set of one or more nodes such that there is a specially designated node called a root. The remaining nodes are partitioned into n greater than or equals to this giant sets T1, Tn, where each of item set is a tree. T1, T2, Tn are called subtrees of the root. Okay. Consider a tree shown in figure below. Tree has 13 nodes. The root node is A.